In this video, I'll be solving the second part of the first problem of UPSC Sales Services Mains 2016 Statistics Paper 1. So let F be a, capital F be a probability distribution function of a discrete random variable. We need to prove that functions f to the power of n and 1 minus f whole to the power of n are also probability distribution functions. So first of all, like we say a particular function h of x. So let's say if we are having h of x. So if this is a distribution function, so first thing is this h of x must be non-decreasing and non-decreasing in x. Secondly, the limit x tends to minus infinity of this h of x must be 0, and limit as x tends to infinity h of x must be 1. And thirdly, h of x must be right continuous. So these are the properties. So these are like the conditions or the properties of a distribution function. So if h is a distribution function, so it will be distribution function if and only if it satisfies these three conditions. So now like if we consider fn of x, so first like we can see 0 less than or equal to f of x less than or equal to 1 for all x. So that implies 0 less than or equal to fn of x is less than or equal to 1. Fx whole to the power of n. So we can see fx is non-decreasing. F of x is non-decreasing in x. So therefore, fn of x will also be non-decreasing in x. And next, like if we consider limit x tends to minus infinity, f of x is 0. So that implies limit x tends to minus infinity, f of x whole to the power of n will also be 0. In the similar way, limit x tends to infinity, f of x is 1. So that implies limit x tends to infinity, f of x whole to the power of n will also be 1. And f of x is right continuous since it's a distribution function. So if it is right continuous, that means the power function, that x to the power of n, so this is a continuous function. So that means f of x whole to the power of n, this will also be right continuous. So therefore, we can see that f of x whole to the power of n is a distribution function. So in the similar way, if I consider like 1 minus f of x whole to the power of n. So if 0 less than or equal to f of x less than or equal to 1, so that means 1 minus f of x. So minus f of x would be in between minus 1 to 0. That means 0 less than or equal to 1 minus f of x less than or equal to 1. So that means 0 less than or equal to 1 minus f of x whole to the power of n is less than 1. So that means again minus 1 less than or equal to minus of 1 minus f of x whole to the power of n is less than 0. So that means 0 less than or equal to 1 minus f of x whole to the power of n is less than or equal to 1. So that means like if 0 less than or equal to f of x less than or equal to 1, that means 0 less than or equal to 1 minus f of x whole to the power of n is less than or equal to 1. So now like if f of x is non-decreasing, so if f of x is non-decreasing, that means 1 minus f of x is non-increasing. So if 1 minus f of x is non-increasing, 1 minus f of x whole to the power of n, so that will also be non-increasing. So that means minus of 1 minus f of x whole to the power of n is again non-decreasing. So that means like 1 minus f of x whole to the power of n is non-decreasing. Now limit x tends to minus infinity, f of x is 0. So that implies limit x tends to minus infinity, 1 minus of f of x whole to the power of n will just be 1 minus of 1 minus 0 whole to the power of n, which is 0. Now in the same way, limit x tends to infinity, f of x is 1. So that implies limit x tends to infinity, 1 minus f of x whole to the power of n would be 1 minus 1 whole to the power of n, which is 1. So And lastly, like if f of x is right continuous, So, and x to the power of n is continuous, 1 minus x whole to the power of n is continuous, and 1 minus x whole to the power of n is also continuous. So that means 1 minus f of x whole to the power of n will also be right continuous. So basically 1 minus f of x whole to the power of n is right continuous. The limit as x tends to infinity is 1, limit as x tends to minus infinity is 0, and the function is non-decreasing. So therefore f of x whole to the power of n, and in the similar way 1 minus f of x whole to the power of n, these both are probability distribution functions. So that's it for this video. We'll meet in the next video.